Good morning, KAP students. This is Monday, November 29th. Welcome back from Thanksgiving break. This is our warm-up. You can pause and play when you're ready. Warm-up. All right, it says the human body is made up of mostly water. In fact, about 67% of a person's total body weight is water. If Cameron weighs 90 pounds, about how much of his weight is water? Now, there's a couple ways we could solve this, but there's one thing that Ms. Lytle's going for. And she probably wants to set up a proportion. Very good. Again, you could have gotten it a different way, but I'm going to solve it with a proportion. And it's just showing you that we can use proportions for so many things. Now, who thinks they can help me set up my proportion? Doom, go for it.
67 over 100.
And why did you choose that?
Because 67.
Exactly. Okay. And then on the other side?
90.
In the denominator, why did you choose to go down there? Exactly. Okay. In a proportion, the top is talking about like the part, and then the bottom is talking about the whole or total. Okay. In this case, the part that we're looking for is that water part. Okay. Now, when I solve proportions, there's a couple ways I can do it. I can go side to side. What else could I do? Up and down. And then if I can't see one way or the other in either one, what could I also try and do? With like just one side, I could try and simplify. Okay. What did y'all do from there? What strategy?
So, I first tried to divide up 190.
Yeah.
And I got 9.
So you like I see that. Can I simplify 67 and 100? Like what could I divide them by? 10. But that's just gonna make it. I mean, yes, but it's gonna make it a decimal. So that's a way. I have tried to avoid decimals. So I technically can't simplify it. Can I go side to side with a whole number? With a whole number? No. Could I go up and down with a whole number? What whole number? What whole number gets me from 100 to 67? That's not a whole number. So I'm asking about a whole number. Whole numbers, do they have decimals? No. So there's not a whole number that can get me there. But there are decimals. So that's what Saki did. So again, we always want to work towards our x. So to go from 100 to 90, it's going to be a fraction or a decimal. If I don't know what that scale factor is, what can I do to get it? I can divide. I would divide what by what? What would I put on the inside? I heard 100 and I heard 90. I'm going to put, because this is my end goal, that's going to go on the inside. That 90 is going to go on the inside, and I'm going to divide by 100. Hey, KAP students, when I divide by 100, what does that do? It moves my, how many times? 2 places to the left. Left. 1, 2, because I'm dividing. 0.90. I know this is a lot already in first period math, and you're like, I don't remember how to multiply periods, let alone with decimals. Welcome back. Hello, we're hitting the ground running. So my scale factor is times 0.90. Times 0.90. When I multiply 67 by 0.90, my answer is. Okay, let's work that out because like no one answered. 67 times 0.9. So we'll multiply with a decimal. I just count the number behind. How many numbers are behind that decimal point? Oh, let's try that one more time. The one that I wrote. There's just 1. Okay, then multiply like normal. 7 by 9 is? Carry that 6. 6 by 9 plus the 6, 60. My decimal moves once, so 60.3. Good. Did we get that answer maybe in a different way? Okay. As long as you get there one way or the other, that is how to do it with the proportion. Okay? So you do have a warm-up paper, so hopefully you have that written down. That can go to the first section of your binder. The other thing you picked up is a bright yellow sheet of paper. Okay, in my class, we're about to take the start part. Oh, I'm not going to put that in the recording, so I'll pause it. Okay, so we just gave out our star charts. So on one side of it has all the conversion. This is like customary and metric. Do you all know the difference between customary and metric? Yes. If you don't, here, let's talk from one thing to another is like times 10, times 100, times 1,000, or divided by 10, 100,000. It's a very beautiful system. Okay. Then there's the customary system. This is the worst, most confusing, nonsensical thing that was ever created. Okay. This is like, you know how there's 12 inches in a foot, and then let's look at that. How many? Do y'all know how many? Okay. It doesn't even say it. In 1 mile is equal to 5,280 feet. Like, does that even like have any sort of like roundness to it, like prettiness? No, it is a random number, and you're like, why? Basically, I'll give you all a history lesson real quick. Basically, there was a king. I don't remember which one, but kings are very much like, it's my way, me. It's all about me. And so, like, they didn't like the metric system, and so they measured a random king's foot, and that became the measurement system. And then it came over to America, and I'm going to show you a map. I do this every single year. I'm going to show you a map of all the places that use the customary measurement system. Again, everywhere else use the metric, but let me just show you. I'm going to pause the recording real quick. All right, so this is a map of all the places that use the customary measurement system. Okay, if you'll take a little notice, the big red thing is America. The second biggest red thing is also America. Because what is that? Alaska. That's Alaska. Okay, and then we got like 2 countries over here. Everywhere else uses the metric system. And guess what? Do we still have to use the metric system? Yes, because guess what? We trade with all the other countries, and it's like, why? I don't know. Okay, it's one of those soapboxes that I stand on. I'm like, why? Why do I have to do this? Let you know, I got it. So, welcome to conversion. So conversions are actually super quick and easy. The way that I teach it. The way that I teach it is with proportions. As we learn with proportions, you sort of want to always keep the same things like part with part, whole with whole, percent with percent, and stuff like that. The proportions that we're going to use today don't involve percents at all, so we're going to get away from like part and whole, but you still want to keep that in mind. Okay. So what we're going to do, we're first going to do with some conversions with customary systems, and we are going to look at some problems together. So we want to convert 20 feet to inches. We want to figure out how many inches that is. Yes, I know y'all can do it. Get quick and easy this in your head. That's awesome. I'm going to show you how you can use proportions as well. Okay, so first off, what are the 2 units that we're using in that conversion? We're using and inches, okay? It does not matter which one you put where in your proportion, just make a decision and you're going to keep that constant. So let's say I want to put feet on top and inches on bottom. That's going to stay the case in my whole proportion. Okay, I'm going to go ahead and draw that out. I'll give you all a second to catch up with me. All right. So let's first look at our star chart. Maybe you have this one memorized. I totally understand. We are converting from feet to inches. So I see that right there. 1 foot is equal to 12 inches. We know that, yes? Okay, that star chart is just there if you need it or forget the conversion. Okay, when I set up my proportion on one side, it does not matter whether it's the right side or the left side, I'm going to put that conversion that it is. I know that 1 foot, notice how it's on the top, 1 foot is equal to 12. Again, I put it on the bottom because that's where my inches are. You good with that? Okay. On the other side, I'm going to put the conversion that I need to find. So that 20 feet, the 20, is that going to go in the numerator or the denominator? The numerator, because that's where I have my feet, and I'm trying to find x, the number of inches. You see how I set that up? Okay, now it's a proportion. Solve it however you want to. You can do side to side, up and down. Raise your hand. What way would y'all like to solve it? Yes, Saki. Side to side. We always want to work towards our x. So how do I get there, class? Multiply by times 20. Do y'all agree? Okay, go ahead and take a second to do that. My answer is, okay, and units, today is the day that they're important, okay? 240 inches, very good. Now, let's just take a quick break. You don't have to like do it the same way I do, or you don't have to erase. What if I had chosen to go up and down? When I go up and down, I still always want to work towards my x. Very good. So if I still want to work this way, my scale factor in this case would be times 12 times 12. And do I still end up doing 20 times 12? Yes, and I'll get the same answer. So it really doesn't matter which way you see it as long as you do it one of the ways. Okay? You don't want me to do one more with you? Sure. Okay? 1.5 gallons to quarts. Maria, what two units do you see being used in that? Gallons and quarts. Okay? Gallons and QTs. Quarts is QTs. Okay? Go ahead to your star chart, put your finger on that conversion once you find it. Okay? Gallons to quarts. Gallons to quarts. I see it right there. What does it say? 1 gallon is equal to 4 quarts. Oh, I know I don't write this down. What if could I have switched it to quarts over gallons? Yeah. I'm gonna do it that way. I'm sorry if you already read it. I'm just switching things around. We said 1 gallon is 4 quarts. Not 4.5. Okay, so what number is going to go in the top? We said 1 gallon is equal to 4 quarts. So what number is going to go in the top? It's 4. I'm going to do it over here. 4 quarts is equal to 1 gallon. Are we good with that? Okay, again, this model is just changing things up to show you that proportion can literally just be done in so many ways. Okay, 1.5, is it going to go in the top or the bottom? Bottom, because gallons is on the bottom. Very good. 1.5. Okay, solving for x. Payment. Do you want to work side to side or up and down? Up and down. Okay, so class, we always want to work towards our x. What's my scale factor in there, guys? Times 4. Okay, ready, set, rock and roll. Okay, my answer is 6, because I need to put my decimal, and I heard someone say it, 6 quarts. QTs is the abbreviation, okay? That's just a little review with decimals. Let's just do one more, because what do I see in that next problem? I see a fraction. Ooh, it's been a minute since we did fraction. Ooh. Ooh. Parker, what unit do you want to be on top of that one? Tons. And then put LBs on the bottom. LBs stands for pounds. Very good. Okay. Setting up my proportion. Will, where's that 3/4 going to go? On the top or bottom? Top. Very good. Doesn't matter which side? No. Okay, so let's put 3/4 here. Do I know how many pounds that is? No. Okay, but I can use my conversion. Michael, tell me what's that conversion between tons and pounds? What's that conversion? 1 ton equals 2,000 pounds. Okay, so what number is going to go in the numerator? 2,000. I disagree. 1, because it's talking about ton. 1 ton is how many pounds? 2,000. Very good. Who sees the scale factor in there? Well, okay, we got it. Side to side, up and down. What do y'all see?
I see one confusion.
Okay. Side to side. Thank you. Where do you see side to side? Okay, so I need to work towards my x. Okay, I'm working backwards, but I'm still working that way. Guys, how do I go from 1 to 3/4? Multiply by itself. What did I just multiply by 3/4? Okay, if I had done up and down, if I had worked towards my x, how do I go from 1 to 2,000? 2 times 2,000. No matter what, I'm going to end up doing 3/4 times 2,000. Now, Could I work this as a decimal? 3/4 is the same thing as 0.75. I could, Miss Libo is going to be here to make your life a little miserable. I want to make sure that we remember how to multiply with fractions, okay? Because it's been a minute. Because we're going to do 2,000 times 3/4. Either way I work it, I need to do 2,000 times 3/4. 2,000 times 3/4. Oh Lord. How do we do that? Anthony, how do we do that? Put it over 1. What else? Multiply. Great. Okay, 2,000 times 3. 6,000 over 4. What can I do? Divide. 6,000 divided by 4. Let's do some speed math. 4 and 6. How many? 0. 0, 0. Okay? Can we still do multiplication with fractions? You can. Believe in yourself.
Yeah.
I don't expect you to do it. I know some of y'all will just turn it to decimal. That's fine. I just want y'all to do that. Okay. 15,000 or 1,500. Is any of this too crazy? No. Great. Merry Christmas. Okay, we're gonna go ahead to number 1. I'm gonna give y'all a second to read it. Yeah, go ahead and read it. Okay, hopefully we've read it by now. What you'll notice is there's a lot of boxes here, like boxes. I'm gonna explain it. This is just this is what we call the problem-solving method. In elementary school, we all learn some problem-solving strategies. Okay, this is another one. You can use it, you can lose it. It's just explaining what's there. So of course we can do conversions and word problems. In this problem, we're finding the weight from pounds and turning it into tons. Very good. Okay. So in any problem, when you read it, you first want to understand. You want to make sure you understand. I know, like I'm going to make just bullet points. I need to convert from lbs to tons. Okay. I understand that. Okay. I'm also, because I have my star chart, I also know the conversion. What do I know the conversion to be from lbs to tons? Thank you very much. We know that 1 ton is equal to 2,000 pounds. Okay? Ooh, that's too many ones. Okay? So, in any problem, you want to first be like, okay, I know this, I know this, I know this. You might not make bullet points, but it's a strategy if you ever get stuck. Okay, and then we like to make a plan. What am I going to need to do in order to solve this? Divide, set up a proportion. If I didn't know that I needed to divide, I could set up a proportion or whatever method you use, proportion, and solve. Okay, I'm going to go ahead and let you know. We will have an exit ticket this week, I believe on Wednesday, where you're going to have to do conversion. Ms. Lytle is going to expect that you do proportions. You can solve it another way, but you will have, points will be taken off if you don't use a proportion. So, again, if you have another method, that's a solid way to check your answer, but you will have to understand how a proportion works with conversions as well. Okay, but hopefully it's not too crazy. Okay, so my plan is to set up a proportion and solve. Now let's actually solve it. So I'm always going to put my units off to the side. Arthur, what do you want to put on top in your proportion? What units do you want to put on top? Pounds, lbs, and then capital T on the bottom. Okay, so because of that, Carrington, what number could I put on the top? If I have pounds on the top, how many? What do I know? 2,000. Okay, very good. And then on the bottom class, I would put 1. Very good, because I know 2,000 pounds is equal to 1 ton. And then what's going to go on the other side? What's going to go on the other side? Anthony. Oh, I thought you were raising your hand. Okay, see. What else did they give us in there? Okay, is that going to go on the top or the bottom? On the top, very good, because that's where my pounds are. 4, 5, 0, 0, 0, 0, and then we're going to solve for x. I'll give y'all a second, write this down. Okay, so someone just asked, how do we know if the pounds or the tons go on the top or the bottom? Okay, the answer is it does not matter. These types of proportions are a little different than percentages, the ones that we did before the break, because we always wanted our whole on the bottom. In this case, we're not dealing with percents, we're not dealing with 100%, so it does not matter which unit goes on the top or the bottom as long as they stay together. Okay? Do y'all look side to side or up and down in this case?
Up and down.
I would have done up and down personally. No matter what, we'll get the same answer, because if I'm working my way down, how do I get there?
Divide by 2,000.
Divide by 2,000. Again, I would know that by online. But again, if you saw it side to side, you could have done that. No matter what did we get as our answer? 225 tons. Are we good with that? Okay, if we mess it up, you may be looking at that other way of solving your proportion. Now, checking. This is probably the thing that KAP students miss or skip the most. Okay, does my answer make sense? Is it reasonable? Okay, when I go from pounds to tons, am I getting bigger or smaller? If I'm going from pounds to tons, am I getting bigger or smaller? 2,000 to 1, is that getting bigger or smaller? Smaller. My numerical value, because technically they're equal, they're the same, yes. But numerically, it is getting smaller. So my answer, if I'm going from pounds to tons, should my number go down or up? Down. Did my answer go smaller from 450,000 to 225? Yes. So that's a reasonableness. You know how when you get to like world problems and there's like way too big of an answer sometimes? Reasonableness. Sometimes they'll don't check for that. Okay? Yes.
You can take away the 0.
You can take away the zeros. There's many ways you can. Yes. In this case, you're not just taking away the zeros. You have to do some other math too, because hashtag customary system. But yeah. Okay. Answer should be smaller. Okay. Just as simple. Does my answer make sense? Kind of check. Okay. I'm just going to keep moving. We are going to skip quite a few problems because I don't think it's necessary, but this is all extra practice. So those problems that we didn't do on the front page, okay, those are extra practice if you need it. These word problems that we're not getting to, extra practice. I'm going to do like one more problem with you, and then I'll let you do free. Okay? The next one we're going to do is the metric system. Okay? Just converting between metrics. It's really no different. Okay? That's why we do a proportion. We just look at our conversion, put a proportion, solve. What number do y'all want to solve? Haley, which one do you want to do? Number 2, the 3,000 meters to kilometers. Okay. What are my 2 units in there, Haley? Meters and kilometers. Which one do you want on top? Kilometers over meters. She likes to change that. Love it. Okay, everyone find that conversion on your star chart. What it be? What is it? A little bit louder. Okay, so on the top I'm going to put 1. On the bottom I'm going to put 1,000. That 3,000 is going to go on the top or the bottom of the other side. The bottom. Very good. Okay, solve for x. Up and down or side to side?
Side to side.
Sure. Side to side. What do we see? Ooh, let's try that one more time. Times 3. Remember those arrows are very important. It tells me which direction I need to work. That would be times 3. 1 times 3 classes. 3 kilometers. Bam, you got it. Okay? Keep working until the class ends.